Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at the uses of electromagnets. Okay, so today we're going to be looking at the uses of electromagnets, and we're going to be answering this question: what are the advantages of using an electromagnet compared to a permanent magnet? So first of all then, a scrapyard crane. So why don't we use a permanent magnet in a scrapyard crane? Well, hopefully it's fairly obvious. A permanent magnet is one that is always magnetic, whereas an electromagnet we can switch off and on. And that's the main difference. So a scrapyard crane, we switch on the electromagnet, we pick up the things we want to, and we move them around, and then we can dump them wherever they need to be dumped. Permanent magnet, obviously, would be a lot more difficult to get the stuff off because the magnet would always be on. Just like all electromagnets, the material that they have to be made of would have to be a soft magnet, so that it would lose its magnetic field as soon as the electricity was turned off, and the magnetic field would be not induced anymore. Right, let's look at a circuit breaker then. So you'll probably in your home have a box that looks like this on the left. It's got lots of switches on it, and all of those little switches are circuit breakers. Now let's have a look at what actually happens. So electric current flowing around your home happily, and it would be a small electric current that if there was nothing wrong, everything would be working absolutely fine. If there was something broken in your home, or suddenly there was an electricity surge and too much electric current flowed, which potentially could be dangerous, and it could be caused by a fault in one of your appliances, then the electric current would be enough to turn on the electromagnet, which would attract an iron lever to it, and then the contacts would spring open, which would break the circuit. An iron lever would be used again because it's a soft magnetic material, and so it won't keep its magnetism. Then what you would do is you'd press the reset switch, everything would go back to normal once you'd fixed the appliance, whatever it was that was causing the problem. Now, circuit breakers have kind of replaced fuse boxes. Fuses are thin bits of metal that you have to replace over and over again if there's a fault. Circuit breakers are a lot easier because you can just press a button and they don't have to be replaced. The other advantage of circuit breakers is that they can detect a much smaller change in the electric current, which means that it makes the whole system a lot safer. Next one then, electric bell. When the switch here is pressed, the circuit becomes complete. This switch is on the electromagnet, which attracts the iron armature towards it. The armature is connected to a hammer, which strikes the bell. As the armature moves, the circuit is broken, so the circuit is broken too. This switch is off the electromagnet, so the armature springs back. Whilst the switch is pressed, this cycle continues. Okay, let's have a look at a relay switch then. So a relay switch you might see in an electric shower, where you might have a pull cord that then switches on your electric shower. So the pull cord would be this first switch, this small potential difference circuit, and then the electric shower would have a large potential difference. Somewhere else you might see it might be in the ignition switch of a car. So the ignition switch of a car is a small potential difference, which would then switch on the larger potential difference for the motor. The way they work then is that first of all you switch the switch for the small potential difference circuit. This small potential difference circuit is one that's just got an electromagnet in it. So when the current flows through the electromagnet, it attracts the iron switch to it in the second larger potential difference circuit, which then switches that on and then makes that do whatever it's supposed to be doing. Next one then, microphone. So there's lots of little bits here in a microphone, so let's go through these. So you've got a permanent magnet in the middle here, this E-shaped thing, and you can see you've got a north and a north pole and then a south pole in the middle here. So we've got electric fields going between the north and south here and the north and south here. Around this central part here we've got a coil of wire, which here is attached to a signal generator. This could be attached to whatever it is that is detecting the sounds, recording the sounds in whatever way. Here you've got a diaphragm which can move backwards and forwards and is attached to the coil here, and then you've got a dust cover. This is just so that the whole thing doesn't get mucky and horrible. So when you make a sound, you can see that the diaphragm goes backwards and forwards, and as it goes backwards and forwards, because of the moving coil around the magnetic field, that induces a potential difference. If that is attached to a complete circuit, like in this case to an oscilloscope, then you can detect the voltages, you can record those voltages, and you can then record those sounds. Okay, last one, a loudspeaker. It's similar to a microphone, just sort of backwards really. An alternating signal passes through the moving coil of the wire, which is attached to a paper cone. This coil sits inside a magnetic field from permanent magnets. These fields interact with the coil and fields a force. Since the current from the wire from the amplifier alternates, the coil alternates back and forth, making the cones move with the same frequency. This creates sound waves as the cone pushes the air in front of it. Okay, so that's the end of the lesson. These are the things you should be able to do. You should be able to state some uses of electromagnets and describe the factors which vary the strength of an electromagnet. You should be able to describe in detail the operation of an electric bell, a relay switch and a circuit breaker. And you should be able to describe in detail the operation of microphones and speakers. So what are the advantages of using an electromagnet compared to a permanent magnet then? So the main advantages are that you can vary the strength of the electromagnets and you can switch them on and off. Okay, so that's been video all about electromagnets and their uses. I've been Mr. Baker. This has been another physics video and I'll see you next time. Thanks very much.